Good morning, ladies and gentlemen. It's a beautiful morning here in Katy, Texas. I hope it's beautiful morning, afternoon, or evening, depending on where you are. Let's go ahead and get started. My name is Andrei Kalinichev, and I'm Director of Upstream Oil and Gas of Dassault Systems. By the way, those of you who are wondering what this logo means on your left side, they can certainly go ahead and take a look at our website and to get more information on what that means. But we'll take next 15 minutes to talk about how we can reuse experience or digital twin experience from other industries in our oil and gas. And I'll give you a couple of examples that are ready today. So let's go ahead and proceed with the very simple white sheet of paper. Totally empty slide. So I removed all the logos, all the legal statements. Let's concentrate on the subject. Now, what I'd like to do is that we go and take a look at the examples from other industries, digital twin examples from other industries. We will look at what this digital twin is, the way it is defined by many people in other industries again, and we will look at examples that we have ready today to be implemented in our oil and gas. Now, aerospace is one of the industries that uses digital twins very extensively, and as you can imagine, complexity of the systems there is quite amazing. Millions of parts, millions of very complicated structures, all sorts of calculations on how they are supposed to live together, and so on. Very nice industry, very high tech, and something that we can certainly reuse in oil and gas. I'd like to mention here that they obviously concentrate on creating a very complex and very detailed and comprehensive static model. And they also concentrate on how this static model can be dynamically modeled to create multiple scenarios, and also model how these parts are going to work together under different circumstances, different temperatures, different pressures, altitudes, and things of that nature. So aerospace is using very advanced digital twins, and we will certainly look at that in the future. Now, life science is something that probably not many of us know, but they made some absolutely fantastic advances there. So they now can create a digital model of the heart of a patient. And not only the model itself, but they can also run virtual surgery to understand, or actually they can run multiple scenarios of how the surgery can be done to understand which scenario is going to be best for the patient and how this scenario can be implemented. So totally amazing technology. And what is really interesting here that it allows us to use expertise, medical expertise from all over the world. So you don't necessarily have to be in the same hospital to virtually operate on the virtual twin of the heart. So that means that we can actually source expertise and required skills from any person who is there to provide that, right? Amazing opportunities for collaboration on how to run these surgeries and how to use this digital twin. So life science and the heart example, truly amazing example of how we can use that as well. Now, the third example is related to cities. And I'm sure that many of you guys have been to Singapore, right? Very nice place, very well organized, well managed, and very clean and very well organized again. Now, not many of you know that Singapore is completely digitally modeled, right? So the entire model of the city has been created, and you can not only model it down to a particular apartment or buildings or roads or facilities, but you can also run simulation scenarios. For example, you can say, what's going to happen if I build another residential area here, how this is going to impact my traffic patterns. So for example, if I'm going to put some industrial facility here, how this is going to impact my residential areas and so on. And again, as I said earlier, you can go down to modeling parking places. You can go down to modeling a particular apartment block, a flat, and things of that nature. So you can go to any level of detail in that model. And of course, very importantly, you can simulate that model. And you can say, for example, how my emergency services are going to respond when there's going to be potentially some pollution happening somewhere, right? So you can look at the patterns, including air, including, again, traffic and movement of people, and basically understand what would be the best response for you to a particular situation or to a particular development and so on. So really amazing digital city of Singapore, and again, it includes a couple of things, right? Number one, it's a static model, if I may say that, and also dynamic model, which allows us to generate multiple scenarios and pick the one that we want to work with in the future. So I gave you a couple of, well, actually not a couple, I gave you 3 reference points, right, on what people do. So let's take a look at a definition of principles of digital twin. Everything starts with the data. Very important. We all know that there's no need to reiterate all of the things about the data. We use this data to create a model. This could be a model of an enterprise, could be a model of a particular object, asset, whatever that might be. Once the model is created, you can actually simulate this model. Once you can actually simulate this model, you can create multiple scenarios of what you want to do. Then, depending on your KPIs and what you want, you always update this model all the time. You always update your simulations using new data which is coming. And then you pick the one that you want. This is a scenario that I want to use in real life, and you take it to your project, to your industry, to your enterprise, to your asset. In this case, I gave you an example of airspace. I gave an example of heart, also Singapore, right? We looked at a nice little video. And of course, the same principles are being applied in upstream and downstream oil and gas. So having said all of that, very important element here is really to grab the knowledge, absorb the knowledge of these digital twins while we are using them, and make sure that this knowledge is being organized and stored in some sort of knowledge base, so people can actually reuse that and use that for constant improvement of these digital twins. This is, by the way, something that we are not doing that well as we should probably in the industry, but constant improvement using the knowledge of how this digital twin works, I think it's a very important and very relevant aspect of what we need to concentrate as an industry if we're talking about this digital twin subject. So other industries are there, and what we did in Dassault Systems, we looked at what could be reused in oil and gas, and we looked at our digital twin experience from automotive, right? Designing cars and running those cars. So we looked at that and we applied one of the projects to oil and gas and carbon storage. And this is what I'd like to quickly mention to you guys. Now, we all know core samples. People who live in the subsurface world in the reservoir world of upstream oil and gas, of course, they know intimately that we use this data in petrophysics, in any reservoir studies and things of that nature, right? So imagine you get your core and rock samples. So what you do, you send it to a lab for analysis, right? And actually, this physical testing may take really long time. By the time you ship it, the lab is going to test it, they send it back, and so on, so on, so on, right? So it's a long process. Also, very important is that sometimes this actually destroys the samples. So you run the test and the samples are not testable anymore, right? So it's kind of has a limited reuse opportunity. It's not necessarily environmentally friendly because you run all sorts of chemical and pressure, high pressure tests on the core sample. It uses facilities, they require maintenance, storage, and so on. And it's also not connected to reservoir workflow, right? Which means that, the data is not directly pluggable. You need to receive this data first, and so on, so on, so on, right? And it costs a bunch actually to do that properly. Now, we use that technology from automotive to take a very high resolution, very kind of fancy image of the core sample, and then you can run digital simulations on that and get the same results. The results take days, maybe super results take 1 week or so. They're completely fully digital, so they're not destructive. So you can run these digital simulations on that image as many times as you want. They have very minimum footprint and environmental impact. They are completely pluggable into your overall corporate memory. So that means that they can be used in your overall data management efforts in the company. And they are fully integratable with reservoir workflow. You get the data, you can put it in the reservoir workflow, and you can use that in your physical studies and your reservoir modeling and so on. And I personally ran some ROI examples on that. Numbers are really mind-boggling. I mean, you're looking at anywhere between 350% to 4,000% ROI, return on investment, that you can get out of that. So it's not really expensive, and it's tremendous value, and you don't actually, you always can rerun this test again if you need that. Now, what I'd like to say, you basically can create a virtual rock lab, a full digital twin of a very difficult and logistic intensive physical process. So this technology comes from automotive. This technology is something that actually we developed together with BP. You can take a look at what we're doing with that. There is an SPE paper on that, and this is something that we already do in quite a few places. Not only replacing the core lab, we actually took it one step further, and you have a fantastic, unique functionality. So for oil and gas, using this technology, you can investigate through multi-phase flow. You can model unique fluid properties, and you can decrease uncertainty. All of that, again, you can use, you can perform based on the data that was based on the results of your digital simulations of those images. So you can eventually get relative permeability, and you can visualize that. You can look at the drainage and many other things like wettability, for example, characterization of your reservoir, petrophysics, and things of that nature. So there's a variety of different things that you can do with this technology, and some of these things are very, very unique to the solver, to the simulation technology that we use in here. Now, what I'd like to do here is to prevent the question. I'm sure somebody's going to say, well, how does that compare with the real tests examples that you get, with the physical testing that you get from the lab? We did extensive and very successful benchmarking. So results are very similar, and now I think we can say that this works. And not only this works, but this is very much comparable with physical testing, and it should actually replace physical testing entirely. Now, for those who are interested, guys, take a look at the SPE. There's an SPE paper. Of course, shoot me an email or call me. I'll give you the number. But there is a study on this that is very much can serve as a reference point. Another thing is that there's a obviously very important subject of carbon capture, right? And the same technology that I showed you right now can serve as a key technology block in 3 different domains in carbon capture. Number one, you can analyze injectivity, which basically means that you can understand how much you can inject safely and nicely without any major issues. Very important, right? For the reservoirs where you pump your CO2 in. You can evaluate your storage, and ultimately you prevent something unfortunate, bad events that may potentially happen, including leaks, and you deliver safe containment of that CO2. So this is something that again can be used today. This is something that we would certainly suggest to consider every time you talk about CO2 capture, and this is something that came from automotive. Amazing, right? So one point that I wanted to make very clear to all of us, that this is something that we are deploying today. So this is not the bright future which is going to happen in the next millennium or something like that. This is something that is ready on this particular afternoon. So do contact me, and we can certainly talk about that. Again, my name is Andrei Kalinichev, right? And here's my email and here's my phone number. Don't forget that this is the name of the company that I work for. By the way, this is one of the largest software companies in the world. I think we're making $4.7 billion revenue or something like that. Now, all the examples that I showed you guys, remember the aerospace and the city of Singapore and the heart, all of these examples are fueled by our digital twin technology, right? So we have an amazing experience in a variety of different industries. And if you want to know what is applicable to oil and gas from other areas of the world economy, please give us a shout. In fact, contact me at the email and the phone number I have here, and I'll be happy to help to connect you to the right person in our organization so we can engage in discussions. And don't forget about this virtual rock lab example that I showed you with respect to running virtual digital analysis on the core samples that can be used directly in reservoir workflows. So thank you very much for your attention, and I hope you have a good day. Thank you. Bye-bye.
Thank you very much, Andrew. We won't forget about the roadmap. Don't worry. I think we all sort of paid attention. I like I like the fact that you presented something that was a bit cross-industry, because I think it was talked about a lot yesterday, how the oil and gas sector needs to learn from other sectors. I mean, the most advanced, I think, is what automotive and sort of down these areas. But you mentioned some other sectors which I think the industry could learn from really well. I wasn't aware of the Singapore one. That's interesting about the Singapore twin. That's a very new. Is that a new thing, by the way?
No, it's not really new, but you know what? Every day we learn new things, Adam. You know, that's how life goes.
I did learn something new there. It's fantastic, actually. Just
It
I'd
is
like to ask
actually.
you a couple of questions, Andre, because you know you yourself. Do you have a cost comparison between doing things the, let's say, the traditional way in quotes, and using a fully digital process? Because that's a good comparison to make.
Yeah, that's a good question. It's all about the money, right? So, and of course, it depends on the field. It depends on how many cores you trying to test and things like that. So, I did very rough analysis. So, let's say if you spent hypothetically $3 million on testing your cores in a particular field, the same analysis could be done digitally for about one third of a price, right? And however, what I'd like to say, cost is not only the value metrics we need to concentrate. I think the most value comes from we can do it in shorter time, so we can actually bring production forward as a result of that. But to answer your question, you're looking at probably 100% being physical and about 30% being digital with respect to cost.
That's a tremendous difference, my God. And one other thing I wanted to ask you, what are your competitors in terms of the people that work within this space? What are your competitors in providing virtual rock lab technology?
So we don't actually have competitors with respect to commercial software. There's only one commercial software that people can go and buy and do what I was talking about. There are some companies who are providing similar services, but they use their own internal IP for that, intellectual property for that, right? So with respect to commercial software, I think we are the only ones. And please, guys, feel free to correct me if I'm wrong, but I think we are pretty much the only provider of commercial software to do that.
You probably get someone on the platform saying, "No, we're one as well."
Oh, that's
So
great.
no,
Let's have an argument. Absolutely.
I think no, it was a brilliant presentation, and for everyone watching as well, you can download this also after the event as well. We're going to be giving everyone instructions on how to download the content. Do also see Dassault's virtual booth. They're on the exhibition floor as well. So any content you wish to download, please go and visit them. They are an innovation partner for the event. Andre, thank you very much for joining me, and it was a brilliant presentation.
Adam, thank you very much. Thank you.